Hello everyone and welcome to my channel. We have to find out the inverse of matrix. So this is matrix A and we have to find out the inverse of this matrix. So please remember this is the pattern, that is this first element is called A11 because this is the first row and first column, and similarly first row and second column. So we write here this one means row and this two means column. So the formula of A inverse is equal to adjoint of A divided by A determinant. So if we have the values of adjoint of A and determinant of A, then we can find out the inverse of matrix. So first of all, we will find out adjoint of A and inverse of A, and then we will put these values in this formula. But remember, if you have A determinant equal to 0, then the inverse is not possible, because if you put 0 over here, so the whole value will become undefined. So therefore, this A determinant must be a non-zero value. So let's start the solution of this question. So we have matrix A which is equal to this. So for determinant of A, first of all, we will eliminate this first row and first column. Then we have -1, 6 and 0, -2. We will write over here, and we will take out this 9 from these determinants or vertical bar, and then we will eliminate first row and second column, and then we will write 5, 6 and 4 -2, 5, 6 and 4 -2, and then we will write this -2 out of this determinant, and then we will eliminate this first row and third column, and we will write this 5 and -1, 4 and 0, 5 -1, 4, 0, and we will write this +1. So from where this minus and plus comes, so please remember, for this first element, that is A11, we will always write plus. Then for this minus, for this plus, minus, plus, minus, plus, minus, plus. So we will run the series like this. So this is by formula, and now we will evaluate all these values. So for evaluation of this, we will add this 9, and now we will multiply these two terms, that is -2 and -1. So when we multiply this -1 with the -2, so it will equal to 2. And then we will write minus in the middle over here. Then we will multiply 0 and 6, 0 and 6, and 0 times 6 equal to 0. And now we will shift to this value. So this -2, then we will multiply -2 and 5. So 5 times -2 equal to -10, and then we will write minus in the middle, and then we will multiply 4 with 6. So 4 times 6 is equal to 24, and now we will shift here. So here we have this +1, and now we will multiply this 5 with 0. So when we multiply 5 with 0 equal to 0, and then minus, and then we will multiply 4 with -1. So when we multiply 4 with -1, so it will equal to -4. And now this 9 and this will become 2. So 9 times 2, and here this -2, and -10 -24 equal to -34, and here this 1 and 0 minus 1 multiply with the minus will become +4. So overall this will become 1 and 2 +4. So 9 times 2 equal to 18, and this equal to 68, because minus 1 multiply with minus will become plus. So plus 68, and this will become +4. So 18 plus 68 plus 4 is equal to 90, which is a non-zero value. So it means that we can determine the inverse of a matrix. So let's now move forward, and now we will find the adjoint of the matrix. So for adjoint of matrix, first of all, we will eliminate first row and first column, and then we will write this -1, 6 and 0, -2, like this. And for this A11, we will write here -1 and power 1 plus 1. So now we will multiply these two terms, so it will be equal to 2, and this 0 times 6 equal to 0. So overall this is equal to 0. And now this is our first element, our cofactor. You can say A11 equal to 2. And now we will determine this A12. So for A12, we will eliminate this first row and second column, and then we will write minus, and we will write here in the power 1 plus 2. So now we will write here in this determinant this 5 and 6, 4 and minus 2, and similarly we will multiply this, so it will become minus 10, and then minus, and we will multiply this 4 with 6, so it will become 24. So now look over here, this minus, and it has power 3, so this minus will come over here, and now this minus 10 minus 24 equal to minus 34, and minus 34 when multiply with the minus, so it will become plus 34. So A12 is equal to 34, and now we will determine A13. So for A13 we will eliminate this first row and third column, and then we will write this 5 minus 1 and 4 0. Now we will multiply these, as this will become 0, and then minus, and 4 times minus 1 equal to minus 4. So this is 0, and then this minus when multiply with minus 4, so it will become 4. So it means that we have A13 equal to 4. So now we have determined A11 and A12 and A13, and these are the values. Now we will find out A21, A22 and A23. So for this, now we will use this second row. So now we will eliminate this second row and first column. So now this will become 2 and 1, 0 and minus 2, 2, 1 and 0, minus 2, and we will write here minus 1 power 2 plus 1, because of here 2 plus 1. So when we multiply this with this minus 2 with 2, so it will become minus 4, and this will become 0. So this minus will shift over here, so we will add minus over here. So minus minus when multiply will become plus, and overall this will become plus 4. And now for A22, we will eliminate second row and second column, and we will write 9 1 and 4 minus 2, 9 1 and 4 minus 2, and here we will write minus 1 and 2 plus 2, 2 plus 2, like this. So now we will multiply this minus 2 with 9, so it will become minus 18, and then minus, and we will multiply 4 with 1, so it will become 4. Now this minus will become positive, so no need to shift here, because it has power 4, and even power convert minus into plus. So now this minus 18 minus 4 equal to minus 22, so its value is minus 22, and now we will move to find out the value of A23. So for A23 we will eliminate this second row and third column, and now we can write 9 2 and 4 0, 9 2 and 4 0, and now we will multiply this 9 with this 0, so it will become 0, and then minus, and then this 4 times 2 equal to 8. So 0 minus 8. Now this will become minus 8, and minus 8, this minus this time, because having power 5, so this minus will shift here. So now this will multiply with this minus 8, so overall it will become 8. So now we have values of A21, 22 and 23, which are these, and now we will find out the values of 31, 32 and 33. So to find out the values of 31, 32 and 33, now we will use this row number 3, and now we will eliminate this row number 3 and first column. So for this, for A31, we will write minus 1 over here and 3 plus 1, and we will write here 2 and 1, and minus 1 and 6 over here. So now we will multiply this, so it will become 12 and this will become minus 1. And because of minus over here, so minus minus will become plus, so it will equal to 13. And now for a 3 2, we will eliminate this and this, so we have now 9 1 and 5 6, 9 1 and 5 6, and now we will multiply this 9 and 6, so it will become 54, and then minus, and this 5 times 1 equal to 5. So now this minus will shift here. So 54 minus 5 equal to 49, and because of this minus, it will become minus 49. And finally, we will determine A33. So for A33, we will eliminate this row number 3 and column number 3, and we will write 9, 2 and 5 minus 1. So 9, 2 and 5 minus 1. Now we will multiply this with this minus 1 with 9, so it will become minus 9, and then minus, and 5 times 2 equal to 10. So minus 9 minus 10 equal to minus 19. So this is the value of A33. Now we have determined all the cofactors of this matrix. So we will put these elements or cofactor in this. So we will put these values which we have earlier determined, and these are the values which we have put over here. But to find out the adjoint, for adjoint we will put all these values over here, and then we will take transpose of this matrix. And taking transpose of matrix means that you will have to convert this row into column. So let's convert this row into column. So now this row will become 234 4 into column, and this 4 minus 22 8 into column, and this row 13 minus 49 minus 19 will be converted into column. So now we have taken transpose of this matrix, and now we have this value. So this is the adjoint of matrix A, and now we will use the formula. So according to formula, A inverse equal to adjoint of A divided by determinant A. Now we have the value of adjoint of A and as well as determinant of A. So we will put these values. So this 90 is the value of A determinant, and we have adjoint equal to this value. You can also multiply this 1 divided by 90 with all these elements. So if you want to multiply this 90 with all these elements, so your matrix will become like this. And further, if you want to simplify like this, 2 and 45, this will become 1 divided by 45, and similarly this will become 2 divided by 45. So if you want to write this in simplest form, you can also write this in simplest form like this: 1 divided by 45 when we divide this by 2, and similarly over here, and this will remain as such. Similarly, we can simplify this 34 by 90 as 17 divided by 45. So all those terms which you can simplify to the simplest form, you can simplify this, and this is our final answer, and this is the inverse of the given matrix. So I hope you will have understand the solution of this finding the inverse of a matrix. Moreover, if you have any kind of question, you can ask me in comment section. Thank you for watching. Goodbye.